Hi DEXTools community, for some time already there is a big debate ongoing about Ethereum, the Ethereum scaling debate. In 2017, the CryptoKitties NFTs caused a spike in the gas fees. 2020, DeFi and yield farming made the gas fees spike again even more, and it got even worse with all the NFT mintings starting in 2021. To explain how Layer 1 and Layer 2s play a role here and to explain the difference between the two blockchain layers, I will first make sure you understand exactly what is meant by Layer 1. Before we start, let me remind you to like that video, subscribe to our YouTube channel and hit the bell button and all that you don't miss out on upcoming videos from our DEXTools Academy. Well, Layer 1 is the base blockchain. Ethereum and Bitcoin are both Layer 1 blockchains because they are the underlying foundation that various Layer 2 networks build on top of. Examples of Layer 2 projects include roll-ups on Ethereum and the Lightning and Liquid network on top of Bitcoin. All user transactions activity on these Layer 2 projects can ultimately settle back to the Layer 1 blockchain. We refer to them as Layer 1 because these are the main networks within their ecosystem. In contrast to Layer 1, we have off-chains and other Layer 2 solutions that are built on top of the main chains. In other words, a protocol is Layer 1 when it processes and finalizes transactions on its own blockchain. So why do we need Layer 2s now, as we can already do what we want on our base layers? I guess many of you heard already about the Blockchain Trilemma. Everyone wants to be the most secure, the most decentralized, and the most scalable blockchain. So far, so good, but we can't have it all without sacrificing one of those three properties. Want a secure and decentralized blockchain, you need to sacrifice scalability and vice versa. The main goal of scalability is to increase transaction speed, to reach faster finality and transaction throughput to get a higher amount of transactions per second without sacrificing decentralization or security. In easy words, Layer 1 and Layer 2 scaling solutions are two sides of the same crypto coin. They are strategies designed to make blockchain networks faster and more accommodating to a rapidly growing user base. These strategies are not mutually exclusive either, and many blockchain networks are exploring combinations of Layer 1 and Layer 2 scaling solutions to achieve increased scalability without sacrificing adequate security or decentralization. For an easy understanding, now I will explain the issue based on the Ethereum network, which most people who are trading decentralized will have come across. The Ethereum community has taken a strong stance that it would not throw out decentralization or security in order to scale. Until sharding, Ethereum mainnet, this is how Ethereum's Layer 1 is called, is only able to process roughly 15 transactions per second. Ethereum has reached a network capacity of 1 million plus transactions per day with a really high demand for those, especially when new NFTs are getting minted. The network causes its gas prices, which are used to pay the transaction fees, to rise substantially. We have seen that in a latest NFT mint where users spent a total of $26 million for the mint. Therefore, the need for scaling solutions has increased in demand as well, because when demand to use Ethereum is high, the network becomes congested, which increases transaction fees and prices out users who cannot afford those fees. That is where Layer 2 comes in to scale Ethereum or any other Layer 1 blockchain. As I said before, the idea of Layer 2 protocols is to solve the speed and cost inefficiencies of the Layer 1 network. Layer 2 is a collective term for scaling solutions that handle transactions of Layer 1 while still taking advantage of the robust decentralized security of the Layer 1. A Layer 2 is a separate blockchain that extends the base layer. A Layer 2 blockchain regularly communicates with a Layer 1 blockchain by submitting bundles of transactions in order to ensure it has similar security and decentralization guarantees. All this requires no changes to the Layer 1 protocol. This lets Layer 1 handle security, data availability, and decentralization, while Layer 2 handles scaling. Layer 2s take the transactional burden away from the Layer 1 and post finalized proofs back to the Layer 1. By removing this transaction load from layer 1, the base layer becomes less congested and everything becomes more scalable. There are various layer 2 solutions in existence. They are categorized into the different solutions to post transactions on the layer 1 blockchains. The most important difference between the different types of layer 2 solutions is the verification process in each of the solutions. To mention a few ones here, the Lightning Network for Bitcoin is based on state channels. State channels are mainly used as payment channels. There are optimistic roll-ups like Optimism and Arbitrum for Ethereum, and although layer 2s are not necessary on Avalanche because subnets provide all of the benefits of layer 2s without centralization, still specific niche layer 2s have already begun supporting the Avalanche blockchain, including implementations of the zero-knowledge roll-ups and other infrastructures that provide a programmable data layer. A well-known zero-knowledge roll-up is, for example, Loopring for Ethereum. Zero-knowledge roll-ups are said to be more advantageous than the optimistic roll-up since it is significantly quicker. Ethereum 2.0 will solve the scaling trilemma with something they call Plasma. Polygon is an independent project that is solving layer 2 for Ethereum version 1. And Solana is integrating the functions of layer 2 directly into layer 1. So they can scale and create smart contracts with the security of the base chain. As you see, different blockchains have different scaling solutions that all have the goal to solve the trilemma of scalability, speed, and security. Let's see where the scaling competition of all the different blockchains we use will lead us in the next years. Don't forget to like the video and see you on the next one. Bye!